Now, our today's topic is sound wave, which is a continuation of what we have been doing in the past. And don't forget, for you to enjoy this topic very well, the first thing for you is to go and read the previous topic. We have started wave since. Now, when we are asked to define sound wave, it's a form of energy generated from vibrating body. When a body vibrates, it will generate sound wave. As I'm talking to you, so my mouth is vibrating, therefore it's disturbing the air in my mouth. That's why you can hear the sound from my mouth. When you disturb the table, you hear the sound wave, and in that case the table will vibrate. When the table vibrates, it will generate sound wave. Therefore, sound wave is a form of energy generated from vibrating body. Now, previously we have classified wave using the two major categories. Now, there was a time we classified sound wave as mechanical wave because it requires medium. So sound wave is a mechanical wave that requires medium. Without medium, you cannot generate sound wave. Then there was another type of classification that are based on direction of vibration of the medium. When the wave travel in the same direction as you are propagating it, we call it longitudinal wave. Otherwise, we call it what? Transverse wave. Therefore, this sound wave, as I'm talking to you, I'm disturbing the air in my mouth in this direction, and the sound also is coming out in this direction. Therefore, sound wave is what? Longitudinal wave. It's not transverse. When a wave travels perpendicular, like if you generate wave in this direction, and the vibration of the medium is also in this direction, we call it what? Longitudinal wave. So an example of that is that of the sound wave. But when we propagate wave in this direction and direction of vibration is like this, don't forget, that's why I said you need to go and watch the previous video for you to enjoy this one very well. If the direction of propagation is like this and the medium is vibrating in this direction, we call it what? Transverse wave. Now, the next thing is velocities of sound wave. Generally in wave, we have velocity v is equal to f lambda, where v stands for speed, then this frequency, f stands for frequency, which is mentioned in hertz, then lambda stands for wavelength. So this is how they are related. Don't forget we derived it in the past. So go and watch the previous video, you will enjoy it. Now, when we say sound wave, velocity of sound wave, velocity of sound wave depends solely on temperature of the medium. That's why you see when you produce sound in the day when the temperature is high, so the sound moves faster in the day than in the night, because velocity of sound wave vary directly with the square root of temperature, and you know the meaning of direct variation. So when you increase the temperature, you are increasing the speed or velocity of sound. Therefore, I've seen question on this. Take note of this formula. So you just have this one. You have V is equal to K square root of T. So from here, make the constant the subject of formula. It shows that K is equal to V over square root of T. So in that question, they will just give you two velocity and one temperature. And whenever you have something like this, since this one is constant, it means V1 square root of T1 is equal to V2 square root of T2. So out of these four parameters, they are going to give you they are going to give you three. Calculate the fourth one. So the next thing is echo. Then what is echo? As we have reflection in light wave that is sending back of light after hitting an obstacle. Generally, when we are discussing about general wave, we have reflection is sending back of wave after hitting an obstacle. Same thing applicable to the sound. When you produce a sound, when it hits a body, it will reflect back, and reflections of sound wave is called echo. That particular sound you will hear after you have produced original sound, when that original sound hits a sinus of it or a body, is called echo. Then that particular echo, is there any useful uses of it? We use it. It is very useful. We use echo to determine the acoustic of building. When you enter a newly built house, just make a sound. You know how strong the wall of the building is. When you make a sound, you see that sound repeatedly, shows that the material used to build house is what? Is strong. But by the time the echo cannot produce itself, it means the material is not what? It's not ordered. Okay, then another one is we used to determine the depth of the what? Of the well. Another one is what? The submarine. Let's say we have the well. I want to know how deep the well is. What I just need to do, I just need to look for a stopwatch. I'll produce a sound here. Then the sound will go like this. Immediately after the sound is produced, I'll start my stopwatch. So the sound will go like this, and you hit this place and it will return back. So in this case, the sound has covered 2 distance of the depth of the well. So if the depth of the well is x, it means it has covered x when going and another x when coming back. Therefore, if I want to find the speed, the relationship between the speed and time taken and the depth of the well, it will now mean speed of that sound is equal to what? Velocity of it is equal to distance covered, which is 2 multiplied by the depth, 2x over t. This question 2 is common. If you are the one that always check past question very well, and they will just give you the speed of sound, the speed of sound in that particular medium. They will give you time to calculate the depth. Some students will now go and use speed is equal to distance over time, which is wrong because the sound has covered 2 multiplied by the depth of the well. And don't forget, another one is they will say a man stand and produce a sound. The sound will go and hit what? The wall. Then it will come back. In that case, it will look like this. You have the wall like this. This is the man standing. So when you produce the sound, it will go like this, cover this x, and it will come back before you hear the echo. So in that case, they ask you to find the distance between you or the distance between the man and the wall. So the same formula, you apply this formula as well. So that is how to determine what? The distance between, the uses of echo. That's another use of echo. You use it to find what? The velocity of sound in air. And what? Another one, the depth of the what? Of the well. Then acoustic of the building. Then the depth of the submarine in the sea. So that is what? Some of the uses of echo. Then another topic is inverse square law of the intensity of the sound. Intensity of sound. That is, if you produce light, where I'm talking now, what is the loudness, the intensity of the sound I'm producing? Then what will now be the intensity of it at a certain distance from where I am? This is Mr. Sulaiman producing the sound. Then this is you as a listener. If the intensity of the sound I'm producing here is what? E0. Then what will be the intensity of it? Intensity of it here. Then the condition is this: the intensity of the sound vary inversely as what? Square of the distance between you and the source of the sound. So if the distance between you and the person here, let's call it what? R. Therefore, the intensity E vary inversely as what? Square of the distance between you. So this is what you are going to hear. The intensity of the sound you are going to hear wherever you are. Then the distance between you and the source of the sound. You have this one remain constant. Intensity at a certain distance R to you is equal to, the constant now is this E0. E0 over R squared. When we remove this one, you have to replace it with constant. And the constant under this one is what? Intensity at the source. The intensity of sound I'm producing now is what? E0. Somebody at another place who is listening to me, what would be the loudness or the intensity of the sound over there? Is this E. Then the distance between me and that particular person is this R. So this formula is called inverse square law of the sound wave. Now the next thing is wave motion. Sound wave. How does sound wave move from one point to another? Now, the movement of sound wave depend, or let's say the intensity of sound wave along its motion depend on the pressure of the air. when sound wave is produced, it comes across the variation in the pressure of the air. Therefore, the intensity also vary. The intensity of sound also vary with that particular pressure. So let's say somebody is producing sound here. So it gets a point when the intensity of the air will be high. So in that case, the wave will close to each other like this. But when the pressure of the air at a particular point is low, in that case, the sound wave will travel like this. So this area where we have high pressure, so the intensity will be here. So whoever is around that particular point will hear the sound clearly and loudly. And that area is called compression. But the area, this type of area, where the intensity is low, therefore whoever is standing around this place is likely not to hear the sound as loud, as clear, like the person standing here. You understand? So therefore, when you are standing around this compression, this area is called rarefaction. So when you are standing here, let's say we still have another person here. So this place is also called compression. So when you are standing here, it is possible for somebody to produce sound here, and you now discover that the person that's very close to you did not hear you as clear as the person that's at the back, that is even far away from you, because that particular person is at what point of rarefaction. Whoever at point of rarefaction is likely not to hear you clearly, like that particular person at the point of what compression, where the air pressure is high. So take note of that as extra property of what of sound wave, that is compression and what rarefaction. Then the next thing is a characteristic of what sound wave. We have three major characteristics of sound wave, and in some past question, you see that they will say which of the following is not characteristic of sound wave. What you need to know the characteristic of sound wave, and as well as what each of them depends on. The first characteristic is what? Pitch. So when we say pitch, we mean the characteristic of sound wave that will make you to identify the series note from less series note. That's the sound that is sweet to what? To the hearing. That you like to hear, different from the one that you close your ear when you hear it. We have some sound like when somebody is dragging iron on the floor. You see that you quickly close your ear. Reason is that the frequency of such sound is not well arranged. Therefore, pitch is characteristic of sound that will make us to identify the sound that is frequency is what well arranged. What those the sound produced by our musical instrument, their frequency are well arranged. That's why you see most of them you may not even know when you'll be shaking your head like this when you are hearing the sound, because the frequency are well arranged. Therefore, the pitch depends on what? Frequency. So pitch of sound depends on frequency. Then the next characteristic is what? Is quality. Quality of sound. So quality is that characteristic of sound that will make you to identify the sound produced from each type of what? Musical instrument we have. So note, this sound is from drum. This one is the sound of the bell. This one is the sound of the guitar. So what will make you to identify the sound produced from different musical instruments is called pitch. It's called quality. And the quality depends on olfactory. So we still talk about this olfactory later in the next topic. Now, the next characteristic of sound is what? Loudness. So loudness depends on intensity. Depends on the intensity of the word of the sound. So that is kind of a characteristic of sound that will make this sound is loud, this one is not what? Loud. And for you to say a sound is what? Loud, depends on intensity. If the intensity is low, automatically the sound will be very, very what? Low. Not only intensity alone, it's also depend on what? Direction of the wind. As I'm talking here, if somebody is standing my front, if the direction of wind is also in this way, the person will hear me louder than when the wind is moving in opposite direction. Another one is what? It also depends on the ear of the listener. You have some people, no matter how close you are to them, if you are producing sound, you have to put your mouth in their ear because of the nature of their ear. Therefore, the loudness depends on intensity, the direction of the wind, and the listener what? Air. Amount of air put into vibration also. So that is that about a characteristic of sound wave. Then the next one is the vibration we have. Don't forget that we said sound wave is a form of energy produced from vibrating body. Then we now have three major type of vibration. We have natural frequency. So when a body is vibrating on its own after being set into vibration. So like there's one clock that normally called our forefather clock. The moment you set it into vibration, you see that it will continue vibrating, moving to and fro. That one is what? Natural one. Then we have force vibration. When we say force vibration, it requires constant what? Force. If we stop applying force on it, it will stop vibrating. Like if you hit the table like this, the moment you stop, the vibration also will stop. And we call it what? Force vibration. But the third one is resonance. When we say resonance is a phenomenon in which a body vibrates as a result of another body vibrating, in which the frequency of that one equal to its own natural frequency. That's that about what? The three major type of vibration we have.